right, ladies and gentlemen, today we're going to look at linear functions. What are they and what do they look like? Well, recall that a function has an input and an output. So what's a linear function? So let's look at the word there. What's the word within a word that we might recognize? Line, right. And so linear functions are an input and an output that make a line. So what is a line? I want you to take a minute on your notes and I want you to write down what you think a line is. All right. You're thinking, Mrs. Woolley, yeah, it's a line. What do you mean? Well, you might have written down that it's straight. There is no such thing as a curved line. They have to be straight. If it's curved, it is a curve. It's not a line. You might have written down that it extends in both directions forever, which is why we put arrows on both ends of our line. And what you may or may not have known is that it really is made up of points. Well, what do you mean? All right, I want you to think of beads. If I took a string and I pulled it really tight, and theoretically that string could go on forever in both directions. And now I want you to take a little bead, a whole bunch of little beads. How many beads could I string on that string? How many beads could fit? Well, if the string goes on forever, I can fit infinite number of beads on that string, right? Now remember, if I had that string going on forever, I could also have beads on the floor, on the wall, on other strings. I also have a whole bunch of beads that may not fit on that string. So what you need to think of is a line is all the points or beads that are the input and the output of that linear equation. And when you put them all together, they're going to be in one direction. They're going to be a line. Now, you only need 2 points to draw a line. We can put an infinitely many on there, but if we're going to draw it, we only technically need 2 points to be able to show which direction we're going. So what kind of things are linear in real life? So here's some examples. Let's see if you can come up with a common theme here. The amount of money you make babysitting each hour. How long you're going to travel if you drive at a constant speed, like 65 miles per hour on cruise control. How much money you'll spend buying songs on iTunes, assuming that all the songs cost the same amount. So what do you think linear equations have in common? Well, they're anything that adds or subtracts the same amount each time it happens. So for example, 12 pieces of candy. I eat 12 pieces of candy every hour for 4 hours after Halloween. Every hour I'm eating 12 pieces. Eating 12 more, eating 12 more, eating 12 more. So it adds the same amount every time it happens each hour. So what I want you to do is to write down on your paper an example that you can think of as something that adds or subtracts the same amount every time it happens. So we'll pause here, write it down on your notes. All right, share your example with your neighbor. See what kind of things they came up with and see if you can agree that it is linear. It adds or subtracts the same amount every time it happens. All right, what we want to know is if just by looking at the equation now, maybe we don't have a story or scenario with it, if I just look at an equation, how can I tell if it's a linear function? All right, well, a linear function has an x, or it has a y, or it has both an x and a y. And you're like, well, all right, that's most equations. Well, linear equations don't have any exponents or symbols. There's no square root symbols, there's no pi symbols, there's no symbols at all. It's pretty much the most boring equation you can think of, just x's and y's and numbers. It also cannot have an x or a y in the denominator. In the bottom of the fraction, there can be no variables. And the last thing is that you cannot multiply an x or a y together. If any of those things happen, you're going to end up with a curve. And remember, a curve is not a line. So here I'm going to give you, there are 5 examples here on your notes, and I want you to take a minute. And we're going to pause here, and you're going to do this on your own. Look at those 4 rules that you have, and you're going to decide, are these linear or not? And you're going to write yes or no beside them. We're going to pause here, and you're going to try and do this on your own. Then we're going to compare. All right, spend a minute Compare with your neighbor, see if you can agree, and then we'll reveal the answers. All right, ladies and gentlemen, let's take a look at these. Is the first one a linear equation? Well, yeah, it has an x and a y. There's no x's or y's in the denominators. In fact, there are no denominators. There's no exponents. There's no symbols. This is a linear equation. And for the same reason, so is the second one. And so is y equals 5. Remember, it could be an x or a y or both. This has just a y, but no exponents or any other thing, so it is a linear equation. However, the last two are not. 6 equals xy. Remember, x and y cannot be multiplied together. And the last one, y equals 3x squared, has an exponent. That would be a curve. All right, let's look. We have three other ones here. These are a little trickier. So now that we have the idea, look back at those rules, see which ones apply, and let's see what they are. Let's take a minute and pause to write down yes or no, and then we'll check. All right, here we go. The first one is a linear function. It didn't say you couldn't have a fraction. It just said you couldn't have the variable in the denominator, which it is not. So yes, this is a linear equation. And so is the second one for the same reason. You can have a fraction just as long as there's no x or y in the denominator. So the last one is not a linear equation because it does have an x in the denominator. Okay, so we can tell just by looking at an equation if it's linear or not. All right, so how can we tell if points are part of a line or not? So I want you to think of this equation, x plus y equals 7. And what I would like you to do is I would like you to come up with three ordered pairs. And remember, an ordered pair is an x and a y, an input and an output. I would like you to come up with three ordered pairs that would be part of this line. Three x and y values that would make this statement true. So we're going to pause here and you're going to write them down on your paper. All right, now I'd like you to compare with your neighbor and see if you had the exact same points that they had, and see if you agree that the points that each other have are indeed part of this line. Now I'm guessing that you didn't come up with the same points, and there's all sorts of combinations we could have had, like 0 and 7, 5 and 2, 2 and 5, 3 and 4. But there's also a whole bunch of other ones we don't usually think of. For example, negative 12 and 19. If I add negative 12 and 19 together, I get 7. And 100 and negative 93. In fact, there is a whole slew of numbers, infinite combinations, in fact, that will add up to give me 7. Now, when I take these combinations of numbers that you had and I put them on my graph, so I had 2 and 5, I had 4 and 3, we had 3 and 4, we had 5 and 2, and all the numbers that you come up with, when you put them on a graph, you can see that when I connect them, they make a line. And this line includes all of those ordered pairs in between that you didn't choose, all the ones that were fractions and decimals and all the things that made x plus y equals 7 true that you may not have considered, and all those other numbers in both directions. So there's an infinite number of points of x and y that are on this line. There's also a whole bunch of points that are not on this line. I could have graphed a whole bunch of points that weren't part of this line. So the way that you can tell which points are on the line are they are x and y's that when you substitute them into the equation, it makes a true statement. So here we go. Here I have a linear equation and I have a point. And I want to know, is this point on this line? All you got to do is substitute in the x and the y to see if it makes a true statement. If it makes a true statement, it is part of the line. If it does not make a true statement, it's a point, but it's just not a point that's on our line. So I want you to pause here. I want you to try this on your own, and then we'll check our answers. All right, let's see. So the first one, if we plug in the 4 for the x and the 14 for the y, and we solve, we get 3 times 4 is 12, plus 2 is 14. True statement. That's part of the line. So 414 is on or part of that linear equation. It is a point on the line. However, the second one, when we substitute it in, 2 times 2 is 4, and 4 minus 6 is negative 2. Positive 2 and negative 2 are not the same value, so no, it's a point, but it's not a point that's part of our line. All right, so what we're going to do today is we're going to graph linear equations. So how we're going to do that is we're going to make a t-chart. We're going to plug in our domain values, our x values. We're going to substitute into the equation and find our y values, our range, and then we're going to make ordered pairs which we're going to graph. So since we're all going to do this, I'm going to demonstrate how that's to be done. So in this particular example, we have the linear equation y equals negative 2x plus 5. And I have a domain of negative 1, 0, 1, and 2. What we're going to do is substitute in each domain value into the equation and find our range. So for the first one, I'm going to substitute in negative 1, and I get negative 2 times negative 1 is positive 2, plus 5 is 7. So our ordered pair, the input is negative 1, and our output was 7. That's the first point that we would graph. And then we're going to do the same with all the other points, substitute in the x value for our domain, solve and get our y value to get ordered pairs. So you can see here's my ordered pairs on the right here. All right, then we're going to have graph paper. We're going to create our x and our y axis, making sure to use the graph paper lines. Do not put your x and y axis in between the lines. You need to use the graph lines that you have, and we're going to order them. And then we're going to plot and label each point. So here are the points we had: negative 1, 7, 0, 5, 1, 3, 2, 1, and 3, negative 1. Remember, the first value is on the x-axis, the second value goes up or down on the y-axis. When we've done this, and if we've done this correctly, when we connect these points, we would get a line. But remember, these are not the only numbers in our domain. We could add a whole bunch more numbers. And so we draw our line through the points with arrows at the end to show that it extends much further than what we've indicated. Okay, then as part of your project, it's going to ask you to circle where the line crosses the x-axis, which is called the x-intercept, and square where it crosses the y-axis, which is called the y-intercept, and to put the title of your equation of the line that you graphed. Then you're going to take your t-charts, you're going to attach them to your graph paper, you're going to staple them and turn them in. This project is worth 30 points. You're going to do it with a single partner. So in groups of 2, both partners need to fill out their t-chart. So once you have a partner, you're going to come to the front, where I'm going to give you both a same colored paper, same numbered, and you're going to fill out your own t-chart. Then before you can get your graph paper, you need to come get it approved so I can make sure that you have the correct numbers and you've done your math correctly. Then you're going to get a graph paper, where you're going to complete the graph, filling out your own x and y axis, labeling and numbering. There is a rubric at the bottom of the t-chart that you have to make sure that you have all of your points. Since you're doing this in color, there'll be colored pens and rulers in the back of the classroom. You are required to use a ruler because we are drawing lines, and lines don't curve. So you're going to turn this in stapled all together with your partner before you leave. And then you're able to, if you're done on time or early, you can start the worksheet, which will be passed out as well. Do not leave tonight without getting that worksheet, because that is due tomorrow in class. All right, ladies and gentlemen, let's go.